Hi, I am Dinakar Raj and my roll number 20951 A0 442 and my branch ECE C section, subject analog and digital communication, and my topic is low complexity rate compatible modulation with hybrid weight set. So first of all, what is modulation? Modulation is defined as the process of superimposing a low frequency signal on a high frequency carrier signal, or there is another definition for this: the process of varying the RF carrier wave in accordance with the information in a low frequency signal. The concepts of amplitude modulation or modulation and demodulation along with their difference are explained below. So in this figure we can observe a carrier signal and input signal. It is nothing but modulating wave. So these are the two figures shown related to modulation. So to do modulation we require two signals. One is carrier signal and the other one is modulating signal. So when we combine these two signals with carrier with the modulating signal, we get modulated signal. This is nothing but modulation. So in this modulation there are three types of modulation. So amplitude modulation. The first one is amplitude modulation and the second one is frequency modulation, and the third one is and the last one is phase modulation. So we have three modulations. One is amplitude modulation and the second one is frequency modulation and the third one is phase modulation. So we can observe different types of modulation with the figures. Phase difference, frequency difference and amplitude difference. We can observe types of modulation. So in detail we can observe and we can discuss different types of modulations and also the definitions. In the previous PPT we have seen the figures of the types of modulation. So in this PPT we are going to see the definitions of the different modulation. In that, first one is amplitude modulation. So what is amplitude modulation? It is a kind of modulation where the amplitude of the carrier signal is changed in proportion to the message signal, while the phase and frequency are kept constant. So what is amplitude modulation? It is nothing but there is a change in carrier signal with respect to the message signal, while phase and frequency are kept constant. This is called amplitude modulation. And the second one is phase modulation. In this type of modulation, the phase of the carrier signal is altered according to the low frequency of the message signal, and hence it is called phase modulation. So it is nothing but, what is phase modulation means? It is nothing but we will alternate the carrier signal. We will alternate the phase of the carrier signal with respect to the, it is nothing but it is according to the low frequency of the message signal. And the last one is frequency modulation. So frequency modulation is nothing but, in this modulation the frequency of the carrier signals is altered in proportion to the message signal, while the phase and amplitude are kept constant. So it is just same like amplitude modulation, but in that we will change the in the amplitude modulation we change the amplitude, but in the frequency modulation we change the frequency, and while the other two are rest, and the rest of two is phase and amplitude are kept constant. This is all about brief explanation about the three types of the modulation. So we know about modulation and also demodulation. Modulation is nothing but we will combine the carrier signal and message signal. But in demodulation, we will separate the carrier signal from the modulated signal. So what is the major difference between the modulation and demodulation? We will discuss in this PPT. So modulation is a process of influencing data information on the carrier, while demodulation is the recovery of original information at the distant end of the carrier. So a modem is an equipment that performs both modulation and demodulation. Both processes aim to achieve transfer information with the minimum distortion, minimum loss, and efficient utilization of spectrum. So it is nothing, demodulation is nothing but we will recover the original information from the modulated signal. So this is the basic difference between the modulation and the demodulation. A low complexity modulation classification algorithm for MIMO and OSTBC system. In this paper, a low complexity modulation classification algorithm is proposed for the multiple input, multiple output orthogonal space time block code system. First, MIMO and OSTBC system is decoupled into several single input, single output system by utilizing the orthogonal property of OSTBC. Then these SISO systems are grouped into several two input, two output systems. Finally, a maximum likelihood based approach is used to classify the modulation. Both the case of perfect and unknown channel state information are considered. Simulations show that the proposed algorithms exhibits significantly lower complexity than conventional algorithm in both cases. Meanwhile, it provides better performance than conventional algorithm in the case of unknown CSI. So this is all about the low frequency complexity modulation classification algorithm for MIMO and OSTBC system. A low complexity modulation transparent and joint polarization and phase tracking scheme based on the nonlinear principal component analysis is proposed and demonstrated via both simulation and experiment. Based on high order statistics, NPCA can achieve joint polarization and phase tracking successfully without any prior information of modulation format. Meanwhile, owing to fact that the estimated matrix is constrained to be an unitary matrix, NPCA can avoid the singulatory problem compared with the format dependent scheme such as CMA and MMA plus VVPP, and NPCA shows comparable bare performance under the back-to-back case and shows fast tracking capability over wide polarization, rotation, rates, ranges. Moreover, for 160Q AM signals, the proposed NPCA based scheme has reduced around 30% computation resources compared with the format dependent scheme, which confirms the advantage of low implementation complexity. The hardware complexity of CMA and MMA plus VVPE and NPCA for polarization and phase tracking are concluded as shown in table 1. The complexity is analyzed based on the principle that the product of two complex values needs 4 real multipliers and 2 real adders. NPCA consists of 3 stages: signal recovery, signal active and reconstruction, and the last one is parameter updating. At the first stage, 16n real multipliers and 10n real adders are used to achieve signal recovery. Then 28n real multipliers and 14n real adders are needed to activate the recovered signal and reconstruct the received signal. The procedure of parameters updating needs 16n plus 12n real multipliers and 15n plus 5 real adders. Thus, the overall hardware complexity of NPCA is 60n plus 12 real multipliers and 13n plus 5 real adders. As a comparison, to achieve polarization recovery, CMA needs 44n plus 12 real multipliers and 28n plus 4 real adders as well as 2n lookup tables. Moreover, 28n plus 60 real multipliers and 14 plus 4 real adders are needed to achieve phase recovery by VVPE for QPSC. Obviously, compared with CMA, MMA plus VVPP, NPC must be a favored technique for polarization and phase tracking in BVTs because power consumption in DSP will be increased. Thank you.